Hi, this is meant to be a very quick overview of what belongs on a graph in a scientific classroom, especially as compared to a math classroom. It's just super quick overview. If this is not enough for you, I have kind of more complete on specifically how to do a graph. But I just wanted to talk to you real quick about some key differences in our two classrooms. Hopefully this is 100% review. As we move forward past this technique is assumed that you will just have it. It's really good because we're going to move on to something a little more complicated right after this. So it's really important that we have these skills nailed down. So if you look here, this is our graphing technique worksheet that pretty much talks about everything that should be on this graph. And I expect all of these things to be on every single graph that we do. So please make sure they are. The main six are this: labels, units, title, scale, data, and line of best fit. Excuse me. So let's talk very, very quickly about what is different between a math class and, of course, a science class. Well, a math class is, of course, focusing on the relationship that you're typically going to see. So, for example, by the way, my son is off camera. If you see any jump cuts, it's because he decided to start yelling. Anyway, a math class typically is focused on the relationship and exactly how to do that particular thing. And therefore, usually the data that is on there is perfect. In other words, it fits perfectly to the line, exactly what it needs to be. It would look something like this. Okay, you did the circle lab either yesterday or the day before, something along those lines, depending on what year this is. And you'll notice that this data, it fits perfectly. All the dots hit exactly where it is they're supposed to. That's because I made it up. The reason this will not happen in a scientific classroom is because pretty much every single graph that we will do in the scientific classroom comes off of a lab. And every measurement coming from a lab is going to have a little bit of what we call error. Error is not a mistake. It's not something that you didn't screw up. You can do a lab perfectly. There's always going to be error. For example, if I attempted to, in this class of V8 Splash, not sponsored, if I attempted to figure out what the volume was specifically of the liquid inside of here, I might pour this out into a graduated cylinder. Well, even though I want to know exactly what the volume is, some of that liquid, just due to hydrogen bonding, is going to hold and adhere to the glass, and it's going to be impossible to get out. So even though I have this measurement of what's in the glass, it's not correct because there's still some left over in that particular glass. That is error. And every single type of measurement that we have in a lab is always going to have that. So that means that just inherently, data does not always fit perfectly to the line. It doesn't always feel great when that happens, but we just got to get used to it. So, for example, if you add this next graph that I made, okay, so this was the data that I made up, okay, this right here is data that was actually measured in a lab. You'll notice that this little guy right here, that little guy right there, does not fit perfectly on the line. Neither does this one over here. And that one's kind of close, but the point is, that's normal. That's going to happen. Okay? Now, let's talk about all those things that you saw just super fast, real quick. Labels, units, title. These are the things that people mostly forget because they go to do the graph and then they forget all the other stuff. This is, without it, it doesn't make any sense. So for title, let's talk real fast. Either one, just describe what lab it is or specifically what you're doing. Or a very general rule that I'm going to use a lot and highly suggest you do is just what's on the y-axis versus what's on the x-axis. So in this case, I have circumference right over here on the y-axis and diameter on the x. So you'll notice it says y versus x. That order is, in fact, important. It does need to be y versus x. Good point, dude. All right, so we talked about title. Labels, obviously these are just what variable you're putting on the y-axis and what variable you're putting on the x-axis. And then units are real easy. What units did you use to measure? This is really important. Talk about why units are so important. But in this class, there's like pretty much not ever going to be a number that does not also have units because that number needs to kind of have context. And so there's the first half. After that, Putting the data on there, I'm pretty sure that's a lot of review. The other main thing to kind of hit on is scale. Okay, now because of making these graphs and not the data not being perfect, one thing that we really want to try to emphasize is the fact that your graphs need to be relatively large. Okay, best way I have to show this real quick is this. I know that a bunch of you, for some reason or the other, like your graphs to be like that big on your page, and you want to try to fit it in there really tight. Not sure why that is, but I know that you do. Okay, now if you look at, let's say this is a tiny graph and a large graph. Now on the tiny graph, let's say that I'm trying to put the data point at this circle, but I accidentally put it there. Okay, now, so I meant to put it here. I'm sorry, I'm supposed to put it there, but I accidentally put it there. Obviously, that's a terrible mistake. We would never want to do that. Okay, but notice this. On the small graph there, obviously that's a huge deal. Okay, if you just simply like cover up, if I can do that real quick, cover up the small graph, and you look at that on the bigger graph, it's kind of hard to see the way I do that. It's not nearly as big of a deal. Okay, simply by making the graph bigger, you're going to make it a lot more accurate. If you make them small, I'm probably going to take off points because I've kind of addressed the reasons why, and it's helpful and it's easier to see when it's bigger. So bigger is better, but obviously you don't want to make it like an entire page. That can be unwieldy. So as you can kind of see on these graphs here, general rule is about a half a page. You should only be able to fit 2 on there. Now with that, scale. As you can see, my numbers here always go up by the same number. Okay. If the numbers aren't perfect, it's kind of hard to know what to expect. But notice this always goes up by the same number. I chose my scale based on what my largest data point was. Okay, my largest data point on this, I think, was 2674. So I have 26 on here. And actually, I didn't need to go. I have 70, 80, and 90. I could have actually stopped at 80. You go past the biggest number and then you stop. But also, I spread it decently out. Scale on the bottom doesn't need to be the same as the side. And then the other big thing to remember, at least for our class, I know this does not usually have to be the case on like a graph in math or something like that, but this bottom point for our class, and I'll talk about the reasons why a little bit later, needs to be 0.00. Okay, I'm not going to have you skip a bunch of numbers and then start. I know that's fine. I know that you do a lot of graphs like that. There is a major reason why we keep that at 00, but we'll talk about that with that more advanced skill that I talked about that was upcoming. Last thing to address is simply the line of best fit. Okay, for our class, I want to say this is the only, I think there's one other equation that's not on here, but for our class, these are the 4 shapes that you're going to see. Okay, they have names. We'll talk more about them later, but for right now, kind of this straight line, this curve down, this curve up, and curve over. Okay. I've made a couple graphs here just real quick, just to kind of show you that. So this lab that I have here is a toy lab. We did it in Physics 2 the other day. So here you go. Okay, it has, this is the height versus the mass of the object. In other words, I think this mass was put on a toy and shot into the air. The more massive it is, the bigger it is, the lower the height. Okay, so what you can see here is that these dots, sorry about that. These dots match kind of the more curved pattern, I don't know if you can see that there, that goes with the shape that is right here. Okay, so if it's a straight line, it's going to be a straight line, and I think the next video I'm going to make is how to find the equation of said line. But if it's a straight line like the one you're seeing here, as you can see, I can't draw a line that straight, so use a ruler. Okay, you can tell from that name that I had this ruler in 2nd grade. Anyway, use a ruler, and basically the rule is you want to go through about the center of all the dots as best as possible. Doesn't have to go through 0, If it does, great, don't worry about it. But you're just going through about the center of the dots as much as you can. Again, bigger graph, the more accurate that's going to be. Even if you're a little high, a little low, it's going to be just fine. With the curved graphs like this one, you're just going to hand draw that. That is actually my hand drawing. And once again, I'm just trying to make the shape, but you'll notice I don't try to connect the dots. I don't go out of my way to hit them. I'm trying to make that shape and go through about the center of the dots while I'm doing it. Okay, so last thing to show you real quick is, let's say I had a graph that looks like this one. Okay, this is a graph that's, I think, dropping objects in a lab, and just from a different height, from a different position, the height goes up here. Obviously, it's going to take longer for those objects to hit the ground. Not very long. You can see we only get up to about 0.7 there. But anyway, the reason I wanted to show you this graph is what you'll notice here is that you might go, I don't see a curve at all. These dots right here look very close to a straight line. And they do. I know they do. They're not, and the easiest way to tell that is when you know the context of the lab, you can ask, does this go through 0.00, or does 0.00 make sense? Now, it's not part of your graph, and I know that's kind of confusing. We'll talk about it a little bit more later on, but does 0, make sense? In this case, we're dropping objects and seeing how long it takes to hit the ground. So if I drop it from 0 height, it would take 0 time. Now, you'll notice I don't have a dot here at 0, because I didn't measure it. But when you consider the 0.00, that curve makes a lot more sense than a straight line that would kind of cut through this spot right here. So again, I'm just going to take this, and it's not going to be perfect, but I'm going to go curve kind of through the center. That's pretty good. Okay. And again, some dots are going to hit nicely, some dots won't. But that's how you do the graphs in this particular class. If you have any more specific questions, like I'll have that bigger video. And if you have questions on how to find the equation of the line, that video comes next.